Hi again everyone, and welcome to the lecture on rheostats and potentiometers. Now, we've already been looking at fixed values of resistors like these ones. So if you were to get a 10k ohm resistor, for example, one that looks like this, it's only ever going to be 10k. It's not going to change from 10k at all, but sometimes we want circuits where we can vary the resistance without having to unplug resistors and put other ones in. Now that's where rheostats and potentiometers come in. Now there's different styles of these. So you've got these rotary ones, so as you rotate it, the resistance goes up and down. You've also got the slider type ones. So as you slide it left and right, the resistance goes up and down. And we've all got all sorts of different sizes. Like we've got these tiny ones here with a little screwdriver attachment. So as you rotate that, I just dropped it on the floor down there, but here's another one. As you rotate it, it varies the resistance. So we'll have a look at these and what they do and some applications of where we'd actually use them. Okay, so let's first start with the rheostat. So here is an example of a rheostat. So this one here is the rotary type one. So as you rotate it left and right, or clockwise, counterclockwise, the resistance goes up or the resistance goes down depending on which way you rotate it. So if we have a look at a bit of the schematic representation, the rheostat looks like this. So you've got your resistor type symbol there, you've got one connection coming up here, and you've got another connection here which is connected to what's called a wiper arm. The wiper arm in this schematic representation can move up and it can move all the way through to the very bottom. Depending on where we position that wiper arm will determine how much resistance we get from this thing. So if you look at this very first one, what we're doing is we've got a 10k ohm resistor, but the difference between this and a fixed one is we can actually vary it all the way from 0 ohms all the way up to 10k ohms or 10,000 ohms. Now hopefully you can see at the moment in this position we're actually going to be getting 0 ohms. The reason for that is if we were to connect this up to an external circuit, just a very basic thing with a power supply, and that's it. Ooh, in fact we shouldn't do that because we don't want to blow up the power supply. Let's just put a light bulb in there and we'll have a look at some circuits like this later. However, the electrons are going to come down here, going to go across here, going to go up around this way through the wiper arm and straight up here. The reason it's 0 ohms is because as far as these electrons are concerned, they don't have to go through any of that resistive material. They just go through this nice piece of wire straight through the light bulb like that. So the resistance of that in this case is 0 ohms. Let me just get rid of all this. That's the little dots, and then we'll go on to the next circuit along. There we go. Now, this one, we've actually positioned it in the middle. So again, this is the same 10k rheostat or 10k variable resistor. We've now rotated it. So we've rotated this, so it's exactly halfway between 0 ohms and 10k. So we're going to get 5,000 ohms or 5k. Connected to the external circuit, you'll find the electrons have to travel up through here, up through here. Now they have to go through 50% of that total resistance there. So they're bypassing all of this part of it. Then they continue on through the circuit, so instead of seeing the full 10,000 ohms, they see 5,000 ohms. So you can see we're moving the wiper arm, or we're rotating it to position the wiper arm somewhere different on the resistive material in order to get a different value of resistance. Now the last one, we've positioned it all the way down the bottom. Again, this is a 10k ohm variable resistor or rheostat. If we position this all the way down the bottom, then all the electrons have to come up through here, through this wiper arm, and they have to go through 100% of that resistance, which means it's going to be the full 10,000 ohms before they continue on in the circuit. And then of course you can position anywhere between the bottom and anywhere between the bottom and the top, and you'll get anywhere between 0 ohms, a short circuit, all the way up to 10,000 ohms. Now of course this, like for example this particular one here, has 10k written on it, which means it can go up to a maximum of 10,000 ohms. But if I was to look at this one, for example, this one says 50k on it. So this can go from 0 to 50,000 ohms. And then we can get other ones. This one here is 500k, anywhere from 0 to 500,000 ohms. And there's lots of variations depending on what you want to use it for. But that is the rheostat. How about a practical application of the rheostat? Well, I'm glad you asked, because here's a circuit. So if we were to get a rheostat and put it in series with a light bulb over here. So I've just made up some values, a 10 volt power supply, a 10 ohm resistance for that light bulb, and the particular variable resistor or rheostat that we've purchased is a 10 ohm variable resistor, which means it can go anywhere from 0 up to 10 ohms. Looking at this circuit, first of all, the electrons are going to come through here, down across. They have to go through the full 10 ohms plus the 10 ohms of the resistor, of the light bulb. So therefore, we're going to be at maximum resistance with that down the bottom, which is 20 ohms. Therefore, if we did 10 volts divided by 20 ohms, the current in the circuit is 500 milliamps. So it's going to be pretty dim, let's say. Let's now move the wiper arm up a bit. So we're going to rotate this a little bit so that we're bypassing some resistance. Have a look at the current. Goes up this way, up through here. It has bypassed 50% of that resistance and just goes straight through there. We still have the 10 ohms of the light bulb, however, now we've only got 5 ohms down here. The total resistance, instead of being 20 ohms, is now 15 ohms. Therefore, the amount of current has gone up. 10 volts divided by 50 ohms, we've gone to 667 milliamps. So it's brighter. More current flow, the light bulb gets brighter. The last one, if we move this all the way to the top, electrons travel through here, up, around, through there, and if you notice this time, they have bypassed all of that. So this looks like 0 ohms. The only thing they've got in the circuit now is the 10 ohm light bulb. So total resistance is now 10 ohms. 10 volts divided by 10 ohms, we're now sitting at 1 amp. So hopefully you can see here that this rheostat in this particular circuit or this particular application is used to dim, or it's a dimmer circuit for that light bulb. You go maximum resistance, it'll be quite dim. Minimum resistance, it's quite bright. Right, that's the rheostat. Then we just move on to the potentiometer, which is very, very, very similar to the rheostat, but now we have 3 connections on it. So in fact, this one I've been holding up before. It does have the 3, so realistically this is a potentiometer. Now the potentiometer, as you rotate it, it does the same sort of thing as a rheostat. It increases or decreases resistance. However, notice that we now have 3 connections. 1, 2, and 3, whereas before we only had 2. 1 and 2. We didn't have a 3rd connection coming off here. And that's because for a rheostat you did not need a 3rd connection. But for this particular one, what we're going to be doing is as we move the wiper arm up or down, it's either going to be getting closer to, I should leave this up, so either the wiper arm will get closer to 1 while moving further away from 3, or the opposite, we'll move it down, it gets closer to 3 and further away from 1. So have a look at a couple of examples here. If we were to have this right in the middle and it was a 10K potentiometer and we measured the resistance between where the wiper arm is positioned and the top leg, you'd be getting 5,000 ohms. If you measure between the wiper arm and the bottom leg, you'd get 5,000 ohms, 5K. It's right in the middle. But if we were to move that up a little bit, so in this case we've moved it, let's say 75% of the way up, hopefully you can see the resistance between the wiper arm and the top connection. Because it's gotten closer to the top connection, there's less resistance. It's now 2.5K. But because it's moved further away from the bottom, there's more resistance. In this case, 7.5K. The resistance of the top plus the resistance of the bottom gives you your full 10K. Let's look at the 3rd example. So if we were to move the wiper arm all the way down the bottom, you can see there is 0 resistance between where the wiper arm is and the bottom connection. However, between the bottom and the very top, there's 10K because it's got all the resistance between those 2 connections. So what we're going to use a potentiometer for is actually a special type of voltage divider, which is a variable voltage divider. So let's have a look. Using the potentiometer as a variable voltage divider. So I've gone back to, well, quite a number of lectures ago now where we had two resistors in series, and if you recall, we can call series resistors a voltage divider, because we're going to have 10 volts coming in this case, and that 10 volts will divide itself amongst these two components. Since we've got a 25K and a 25K, they're exactly the same resistance, they will get exactly the same amount of voltage, therefore we get 5 volts there, 5 volts there, 5 plus 5 is 10. If we ever wanted to have the top resistor get more than 5 volts, we'd have to take out that top resistor, replace it with a bigger value of resistor compared to the bottom one, and now we could start to get more or less depending on how we swap them. However, a potentiometer does that all for us. We just need to rotate this back and forth, and we can vary how much resistance is between the center wiper arm and the top connection and the center wiper arm and the bottom. But first of all, just have a look at the equivalent circuit over here. So this here with two fixed resistors is going to do the same thing as this one with one variable potentiometer resistor. If we were to purchase a 50K resistor, put the wiper arm right in the middle, so we rotate this so it's in the middle, or we position this so it's in the middle. There'll be 25K between the wiper arm and this side, and 25K between the wiper arm and this side. If we apply 10 volts to the whole thing, therefore you're going to get 5 volts there, 5 volts there. But what if we do start to move this? So let's say I move this all the way over to that side, or in fact let's try and do it like that, the way the pitch is going to be. So look down the bottom here. If I was to move the wiper arm further up, see how the resistance between here and here would be less because it's closer to there. However, the resistance between the wiper arm and the bottom is more because it's further away. If we had 10 volts across this whole thing, that voltage plus that voltage will equal 10. Ooh, in fact, it looks like I've deleted part of the 10. Let's put it back in. There we go. Everything's good again. So 10 volts across the whole thing, that plus that will equal the full 10. But now if you notice between there and there, it's not going to be 5 like it was when it was in the middle, it's going to be less than 5. In this case I've said you get 2 volts, therefore the bottom would be 8. So 8 plus 2 gives you 10. So we can see that in the circuit here. I've moved the wiper arm up, there is less resistance there compared to here. So it's just like me building this circuit over here where we've got a 10K resistor up the top, a 40K resistor down the bottom. The 40K is going to get most of that 10 volts while the 10K gets a little portion of it. So a potentiometer can be used as a variable voltage divider. If we move this all the way up, between the bottom and the wiper arm, you'd get the full 10. Move it all the way down, between the bottom and the wiper arm, you'd get 0, because the full 10 would be between the top and the wiper arm. So we can vary how much the top and the wiper arm gets, and the bottom and the wiper arm. But you may be asking, yes, that's all good, but what's the point? Well, how about I play a retro ball video, and that's going to appear here. Retro ball is a game that I made a few years ago. For those of you who are old enough, if you remember back in the 70s, I think it came out, it was a game called Pong, and then there's variations since then. I made an LED game called Retro Ball, which is a 4-player variation of Pong. Now in order to play the game, you've got your little paddle, and the paddle moves back and forth, and then the balls come and you've got to hit it off so so you don't lose a point. The way the game is played is every player has a potentiometer, and they rotate this. As they rotate it, their paddle moves left and right. So you rotate it this way and it moves that way, you rotate it this way and it moves that way. So we've got 4 of these circuits here. Now we're not concerned with getting the voltage between here and here. We're just concerned with getting the voltage between here and here. So if and by the way, I've got this little note there that it says here, rotating the potentiometer clockwise or anti-clockwise causes the voltage that is sent to the retro ball circuit board to go up or down. And we'll talk about this in a later tutorial, but we're going to be using 5 volts as our power supply. Therefore, we can go wiper arm all the way down the bottom here, and you'd get 0 volts between there and there. However, if you rotate it so it goes all the way up the top, you're going to be getting 5 volts between there and there. And then, of course, you've got every other variation in between. But then what the retro ball circuitry does is, it's receiving this voltage, and it goes, okay, well, I'm getting 0 volts in from this player over here. So 0 volts means I need to position this all the way to the extreme left. But then as the player starts to rotate the potentiometer, the voltage goes up and up and up, and then retro ball circuitry keeps moving this across, and then we get all the way to 5 volts, which means this has been rotated so far as it's all the way at the top. 5 volts comes out, and then this will be over to the very right hand extreme. So 0 volts is all the way here, 5 volts is all the way over here. So that is where we can use, that is a practical application of a potentiometer. We also use them in audio volume control, so you want to listen to more music or make it louder, you can rotate it one way and you get more voltage going through to your amplifier, or rotate it the other way and you're getting less. And many other applications as well. And I've said here, by the way, a potentiometer can be used as a rheostat. Just leave off one of the pins. So here's my potentiometer. Here's a rheostat. In fact, this one here I've pulled apart to show you guys a bit later. So this one has 2 pins on it, rheostat. This one has 3, potentiometer. You can use a potentiometer as a rheostat, just disregard one of the pins, and it works. So there's my 3rd pin. However, we just leave it off, and you can see we just use the wiper arm pin and one of the other ones, and it works as a rheostat. Alright, so now let's have a bit of a look at the internal workings of one of these. So we have here a rheostat. This one here you rotate to increase or decrease the resistance, and there's our 2 connections there. This one over here happens to be the wiper arm, and this one over here happens to be just the fixed one side of the resistor. So we'll pop this thing open, and you'll see this one separates, but that actually has an electrical connection to this here, and that's the wiper arm. So as we rotate this, there's one end stop there, can't go any further. This one here goes all the way to this one. So in that position, and if I was to put this back on top, if I was to measure the resistance between there and there, it would be 0 ohms. Because this bit of metal on here connects to this bit of metal on here, which is then directly connected to this bit of metal, 0 ohms. As I rotate it through, so this little round strip here is resistance wire, so the further that I rotate it this way, the more resistance there's going to be between this connection and this connection at the moment. So if I measure between there and there, I'd be getting 50% of the total resistance, because it's going through 50% of that wire. To get maximum resistance, I'd go all the way over to this side. So now between this wiper arm bit here, if I was to put that back on, we'd go from there. It has to go all the way through that resistance winding, all the way to there. And that's it. That's the internal workings of a rheostat. A potentiometer, they just have another connection coming off here, and you'd have the 3rd pin coming out, just like we would with this one. So you're either rotating the wiper arm closer to this side, or you're rotating it closer to that side. And that is it. So go and see how you go with the quiz questions.